Hey everyone, welcome back to Math with Pi, and we're going to be going over some AP Calculus BC for your response questions in preparation for the upcoming AP exams. So this is our 2018 FRQ. It's number 3 on the no calculator portion. And let's get started. So the graph of the continuous function g, which is the derivative of the function f, is shown above. That means that g of x equals f prime of x, right? Because the graph is the derivative of the function f. Now, the function g is piecewise linear for -5 inclusive is greater than or equal to x is less than 3. So from this range, it's piecewise linear. And taking a look at our graph, we can confirm because it's just a bunch of lines with different slopes. And so, yes, it's piecewise linear. And then between 3 and 6, we've got this quadratic that they talk about over here. And yeah, it looks like a quadratic, or at least part of one, and so the equation makes sense. So just checking that our graph lines up with what's in the problem. And so part A says, if f of 1 equals 3, what is the value of f of -5? Well, when we're talking about the f of x, we're talking about the integral of something, right? Because in this case, this is the derivative of f. So f prime x is d dx of f of x, and we're just doing some differentiation here. And therefore, the integral of f prime of x dx is going to give us f of x plus c. Let's not forget that constant. So, essentially, we're going to be integrating in this problem when we're taking a look at the values of f of x. Okay, so we already know g of x equals f prime of x. And then we're given that f of 1 equals 3. And what that really means is, in this integration portion, when we've got this constant c, the constant is in such a way that the value at 1 is going to be 3 on the graph of f of x. Note, this is not f prime. This is on the graph of f of x. And the derivative really only gives us the slope, right? Which means it gives us the change that's happening in the graph. But the change means nothing unless we have what I like to call an anchor point. And that's a point that's an initial value, or it's a point that we can relate that change to. Where is it changing from? So we've got this point f of 1 equals 3, and that means that at x equals 1, f of x equals 3. And anything we do from there, we're just adding or subtracting the area depending on whether the area is over or under the curve. So what is the value of f of -5? Well, I'm going to set up an integral such that I say, what is the value of f of x? The value of f of x is going to be, let's start at x equals 1 because we know the area there, or the point there. So f of 1 is going to be 3. Right? Except f of x needs to relate f of 1 back to all other values of f of x. So it's going to be 3 plus the integral from 1 to x of g of t dt. Now, where did this g of t come? Well, if I'm integrating with respect to x as one of my bounds, I need to set up my function in terms of another variable. I can't have x as a limit and then have g of x as my function. So going back to some basic rules, we're going to write that in terms of t, and we're going to integrate with x as one of the limits, so that we say the area from 1 to any x is going to have that area between, so the area from x to any number is going to be the area from 1 to x plus the area from that number to 1. Okay, so next we want to know f of -5, right? So when I say f of -5 equals 3 plus, evaluate from 1 to -5, g of t dt. Just to make this a little easier for myself, I like to go from left to right, so -5 to 1 instead of 1 to -5. So remember, that can just become a negative when I flip the limits. And I'm going to put my -5 as my lower limit. All right, so I got that now. And now I'm actually going to evaluate it. And they've given us, so this is piecewise, and I might need to go piece by piece. I can't just plug in one g of t to evaluate. So taking a look at this, we're going to go, what's the value from -5 to 1, the area under the curve. So the area under the curve from -5 to -2 is going to be 1, 2, 3, 1, 2, 3. So 3 by 3. So 3 minus a 3 by 3 square. And remember, that's also negative because it's under the curve. Minus another under the curve segment, which is a triangle. It's going to be 1/2 times the base, which is 1, times the height, which is 2. Or rather, -2. And then we've got from -1 to 0, our area under the curve is 0. And then from 0 to 1, our area under the curve is plus 1/2 times a base of 1 times a height of 2. Oh, hang on, actually. Earlier, our segment should be, it has a height of 3. Okay, that was my bad. So, right over here we have this. And so it should evaluate to -1 minus 3/2 minus 9 plus 3, which is equal to 8 plus 3/2 plus 3, which is equal to 11 and 3/2. And that is your area under the curve. We can write this as 12.52. There's part A. Our next video will have part B.